Number one says, if find d2y dx square if y equals e raised to power 5x plus 3. That means find the second derivative of y equals e raised to power 5x plus 3. First of all, let's find dy dx. Let u be equal to 5x plus 3. That means y will become u raised to power, no, y will become e raised to power u. U is 5x plus 3, so y will be e raised to power u. And now that means dy du will be equal to e raised to power u, and du dx will be equal to 5. So that therefore means dy dx, which is dy du times du dx, is equal to e raised to power u times 5, and that's equal to 5 e raised to power u. That's dy dx, which simply means 5 e raised to power 5x plus 3. Now d2y dx square is what we'll get when we differentiate this. So that will be 5 into bracket. I already know that if I differentiate e raised to power 5x plus 3, I'm going to get 5 times e raised to power 5x plus 3. So I'll just write the answer again: 5 e raised to power 5x plus 3. I say that again: if I differentiate e raised to power 5x plus 3, I'm going to get 5 times e raised to power 5x plus 3. So d2y dx square will be 5 multiplied by what I'll get if I differentiate e raised to power 5x plus 3, which is 5 times e raised to power 5x plus 3. And the final answer will now be 25 e raised to power 5x plus 3. And that's it, very, very simply. Number 2, what does that say? Differentiate cos theta minus sin theta, the square of cos theta minus sin theta with respect to x. Let y be equal to cos theta minus sin theta, and you have the whole of that is squared. Now you have the square of the whole of that. Put u equals cos theta minus sin theta. That means y will become u square, and dy du will be equal to 2u, while du d theta rather will be equal to, because u is written in terms of theta, du d theta will be equal to, when we differentiate cos x, we get, when we differentiate cos theta, we get minus sin theta, minus, when we differentiate sin theta, we get cos theta. And that simply means dy d theta is going to be dy d theta, because y is written in terms of theta, not in terms of x. So that means dy d theta, which is equal to dy du times du d theta, will be equal to du times minus sin theta minus cos theta. And that simply means 2u into bracket, let me write it this way, minus sin theta minus cos theta, which simply means minus 2u sin theta minus 2u cos theta. I don't think I need to write the step. It's a repetition of a step. So that's what we have: minus 2u sin theta minus 2u cos theta, and that simply means minus 2. U is cos theta minus sin theta, minus 2 cos theta minus sin theta minus 2 minus 2 Okay, I think I can even just leave it this way from here. Let's just write it this way. That's 2u, which is cos theta minus sine theta times, or okay, I think this is the best way to put it. Let me factor minus 1 out of minus sine theta minus cos theta. So that will be minus 2u into bracket sine theta plus cos theta. What I've done there is 2u times minus 1 into bracket sine theta plus cos theta. Then minus 1 can multiply 2u to give minus 2u. So we have minus 2u into bracket sine theta plus cos theta. And we know what u is, so that's minus 2 into bracket cos theta minus sine theta, cos theta minus sine theta, into bracket sine theta plus cos theta, which is the same as cos theta plus sine theta. And I can see that this is a difference of two squares. So that's the same as saying minus 2u. That's the same as saying minus 2 into bracket cos square theta minus sine square theta. Cos square theta minus sine square theta. And that's the answer, very, very simply. Now we go to the next one. We go to number 3. Differentiate a y equals cos 3x. 3a y equals cos 3x. Let u be equal to 3x. That means y equals cos u. dy du will be equal to minus sine u, and du dx will be equal to 3. So dy dx, therefore, which is dy du times du dx, will be equal to minus sine u times 3, which is equal to minus 3 sine u, and that simply means minus 3 sine. We know what u is. U is 3x. Now we do the next one, b. Differentiate y equals the square of 1 plus x. If y equals the square of 1 plus x, what is dy dx? Let u be equal to 1 plus x. That means y equals u square. Dy du will be equal to 2u, and du dx is equal to 1. So dy dx is therefore equal to 2u times 1, which is dy du times du dx. And that simply means 2u, which is 2 times 1 plus x. That's 2u. U is 1 plus x. And the next one, which is question C, is y equals minus 2x plus 3 raised to the power of minus half. If y equals 2x plus 3 raised to the power minus half, what is dy dx? Let u be equal to 2x plus 3. That means y will be equal to u raised to the power minus half, which simply means dy du is equal to minus half u raised to the power. Minus half minus 1 is minus 1 and a half, which is minus 3 over 2. and du dx is equal to 2. Du dx is equal to 2, and that simply means dy dx is equal to dy du times du dx, and that is minus 1 over 2 u raised to power minus 3 over 2 times 2. These 2 can cancel this 2, and we'll be left with minus u raised to power minus 3 over 2, which simply means minus 1 over u raised to power 3 over 2. And that's the same as minus 1 over u is 2x plus 3. U is 2x plus 3. And that simply means minus 1 over 2x plus 3 raised to power 3 over 2. And that's it, very, very simply. Now let's go to the last one, which is 3D. Differentiate y equals 2x squared plus 5 all raised to power 5. First of all, let u be equal to 2x squared plus 5, and that simply means y will be equal to u raised to power 5, which means dy du is equal to 5u raised to power 4, and du dx is equal to 4x. If you differentiate 2x squared, you get 4x. If you differentiate 5, you get 0. 4x plus 0 is 4x. And that therefore means dy dx, which is dy du times du dx, will be equal to 5u raised to power 4 times 4x, which simply means 5 into bracket u is 2x squared plus 5, so that will be 5 into bracket 2x squared plus 5 all raised to power 4 times 4x, and that simply means 20x into bracket 2x squared plus 5 all raised to power 4. And that's it, very, very simply. That is dy dx.